Hi, this is Kevin, and today we're going to talk about conditional probability. It's a very simple concept, but you need this in order to explore other, more complex ideas in math and science and software design. Let's take a look.
Before we start, let's talk about dependent and independent events. Two or more events are dependent if they are related with each other. Two or more events are independent if they don't have anything to do with each other. One event doesn't affect the other event in any way. Let's look at some examples. An example of dependent events are picking a card from a deck, not putting it back, and then picking another card. Because when you pick the card a second time, the number of cards to pick from is smaller. An example of independent events are picking a card from a deck, putting it back, and then picking up another card. Because you are picking a card from the same deck, with the same number of cards all over again. Another example of dependent events are picking two people with blue eyes from a family, because having blue eyes within a family is a hereditary trait. An example of independent events are randomly picking two people with blue eyes from a country with a large population. Choosing one person randomly from a large country doesn't really affect your choices for picking another person with blue eyes in the same country. Yet another example of dependent events are parking illegally and getting a parking ticket, because you can only get a parking ticket for parking illegally. An example of independent events are parking illegally and getting a lottery ticket, because getting a lottery ticket doesn't really have anything to do with how someone parks. I hope that my examples have made it clear that dependent events affect each other in some way and independent events do not. You can check whether events are dependent or independent by determining if the probability of the first event multiplied by the probability of the second event is the same as the probability of the two events occurring. Now let's look at conditional probability. Suppose there was an election. Some of the voters were male and some were female. Some people voted yes and some people voted no. We also assume that being male or female has nothing to do with how someone voted. That is, they are independent events. If we tally up the votes and put it into a table, we can see that there were 11 people. 8 people who voted yes and 3 people who voted no. We also see that there were 7 males and 4 female voters. We can calculate the probability that someone voted yes as 8 over 11, because there were 8 yes votes out of 11 people. The number of people who voted no is 3 over 11, because there were 3 no votes out of 11 people. We can also determine that the probability the voter is male in this election is 7 over 11, because there were 7 males out of a total of 11 voters. What is the probability that a voter voted yes, given that the voter is male? This is conditional probability. It tries to find the probability given a condition. You can see that there is a little bar symbol between yes and male. This is like saying given. So this whole thing says the probability that the voter voted yes given that the voter was male. The answer is 5 over 7. There are 7 males, and given that, 5 of them voted yes. So the probability a voter voted yes given that the voter is male is 5 over 7. The probability that the voter voted yes given that the voter is male is different from the probability that the voter is male given that the voter voted yes. There are 8 people who voted yes, and 5 of them were male. So the probability that the voter is male given that they voted yes is 5 over 8. This is different from the probability that the voter voted yes given that the voter is male. Let's look at some examples. A middle school had a survey to determine what the favorite food of their students were. The data is shown in the table here. So, what is the probability that a 7th grader likes ice cream? Using conditional probability, we can write it out like this. The probability of ice cream, given that the student was a 7th grader, is 9 over 32. Because there are 32 students in the 7th grade, and 9 of them like ice cream. What is the probability someone who likes ice cream is a 7th grader? So this is the reverse of the first one. Well, you can write it like this. The probability of a 7th grader, given that they like ice cream, is 9 over 23. There are 23 people who like ice cream. 9 of them are in the 7th grade. Here's another example. A high school has 3 sports: swimming, football, and basketball. There are 2 coaches, Coach White and Coach Green. The number of wins in each event is given in the table shown here. What is the probability that the football team will win if Coach White is the coach? Well, in conditional probability, you say that the probability that the football teams win, given Coach White is the coach, is 8 over 13. This is because Coach White coached 13 games and the football team won 8 of them. The probability of Coach Green winning, given that it is a swimming event, is 7 over 11. So there are 11 swimming events, and Coach Green won 7 of them.
Well, that's all I have for conditional probability. In the next videos, we'll look at how to use this with other useful ideas. By the way, if you like this video, please remember to hit like and subscribe. I hope you had a good day, and bye for now.